In this video, we're going to talk about dilutions of solutions and how to actually calculate out different dilution quantities of solutions. First off, there are a lot of different ways to calculate out concentration, but most often in chemistry we use molarity, which is abbreviated as capital M, or brackets around something. Remember that molarity is moles of solute per liter of solution. While we're doing labs throughout the year, there are a lot of different concentrations of solutions that we need. For example, concentrated hydrochloric acid is 12.1 molar, but we usually use solutions ranging between 0.1 and 5 molar hydrochloric acid. Instead of keeping all of those solutions on hand, usually what we do is keep the most concentrated one on hand and then dilute that most concentrated one to whichever solution we need for a specific lab. For example, if we need a 6 molar HCl solution, we'll use the 12.1 molar solution and dilute it down to a 6 molar solution for that specific lab. We just don't have enough room in the stockroom to carry thousands and thousands of different concentrations of the same solute solution. When you're doing a dilution, the solute doesn't really change. What you're changing is you're adding more of the solvent in to dilute out the solute, but the actual solute molecules are the same. Another way of saying what I just said is that we're increasing this, which makes the molarity less. We are not decreasing the moles of solute. This is staying the same, but we are increasing this. And you guys know from algebra that when you increase the denominator, the number gets smaller. So that's how we get a smaller molarity, or a more dilute solution. The equation that's used for doing dilutions is M1V1 equals M2V2. M stands for molarity, so molarity of solution 1, molarity of solution 2. V1 stands for volume of solution 1. V2 stands for volume of solution 2. All the equations that we see in chemistry that have 1s and 2s, the thing you're going to notice is that whatever the units are on one side, that has to be the units on the other side. And what that means is if volume is in milliliters over here, then if we solve for this, this is going to be in milliliters. And molarity obviously is going to be moles per liter on both sides. So whatever the units are on one side of the equation, those automatically will be the units on the other side of the equation. The problem I gave you said if I wanted to make 30 milliliters of a 2.0 molar solution, that should be solution SOLN, from a 5 molar solution, how could I do this? And so this is obviously a dilution problem because we are taking a more concentrated solution and making it less concentrated. So we're going to use this equation that I mentioned up above to solve this. So I'm going to make M1 equal 2.0 molar, and we know that V1 is 30 milliliters, M2 is 5.0 molar, and we are looking for V2. So now we're going to solve this. 2.0 for M1, 30 for M2, equals 5.0 for M2, and our V2 is kind of our X or question mark. So if you solve this, what you'll find out is that V2 equals 12, and that would be milliliters, because on this side, this was in milliliters. So we need 12 milliliters of the more concentrated stuff. So the way we would actually make out this solution, if we needed to, is we would pour into a beaker or something else 12 milliliters of 5 molar solution. So that's going to be sitting down here. And then we would need to add water to that to dilute it. And remember, in the end, we wanted 30 milliliters. So we're going to need to add approximately 18 milliliters of water to this, and that's going to dilute it out and make a 2.0 molar solution. Then it'll be 30 milliliters of a 2.0 molar solution. The next problem I have on your note sheet says, if I add 25 milliliters of water to 125 milliliters of a 0.15 molar sodium hydroxide solution, what will the molarity of the diluted solution be? Just the fact that we see this word diluted tells us we're going to be needing to use M1V1 equals M2V2. Okay, in this case, the first molarity I see is 0.15 molar, so I'm going to make it M1, and it looks like we have 125 milliliters of that. M2, we have no idea what that's going to be yet. Now here's the tricky part. The volume of the new solution is not 125, it's not 25, but it's the 125 plus the 25. So the amount of the new solution that we have is 150 milliliters. So now that we have all these variables here, M1, V1, M2, V2, we can plug in and go ahead and solve the problem. So 0.15 times 125 equals M2, which is kind of like our X that we're looking for, times 150. And notice that I made sure that because this was in milliliters, that I went ahead and kept this in milliliters. And now doing our math and solving for M2, you should get M2 to be 0.21 molar. And I rounded this to 2 sig figs based on all these numbers I was given here. So there's my final answer for this problem.